Our new topic is on theorems on secants, tangents, and segments of a circle. At the end of the lesson, you would be able to identify and illustrate the theorems on secants, tangents, and segments of a circle, and be able to solve problems using theorems on secants, tangents, and segments of a circle. Now let's get started. Let us begin with the theorems on tangent line. So, for number 1, it says that if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So, if you are given this figure, we say that if line CB is tangent to our circle A at point D, which is the point of tangency, then this line is perpendicular to the radius AD. And we know that perpendicular lines forms a 90-degree angle or a right angle here. Let's have this example. So questions that deal with this theorem usually go hand in hand with the Pythagorean theorem. That is because you can only use this theorem if you have a right triangle. So, for example, given this figure, we are asked to find the length of AB or the length of this radius. So what do we do? If CD is a tangent, find the value of x. So we will be using the Pythagorean theorem a squared plus b squared equals c squared. So c squared here is always the hypotenuse. So we substitute the values. So our a here is x. This one, CD is 8. And of course, the longest leg is the hypotenuse, which is 10. So, we square x, which is x squared. We square 8, which is 64. And the square of 10 is 100. Applying the addition property, so we transfer our 64 to the right side of the equation. That's why we have x squared equals 100 minus 64. And then we subtract this. We have x squared equals 36. So, since we are solving for x, we get the square root of both sides. So, we square both sides. So, the value of x is 6. So, it means that the length of radius AD is 6. Let's have the second theorem. If a line is perpendicular to a radius of a circle at its endpoint that is on the circle, then the line is tangent to the circle. So again, if you have this figure, if RT, line RT, is perpendicular to the radius, which is SQ at point S, then we can say that RT is tangent to the circle Q. Let us deal with theorem number 3. So if two segments from the same exterior point are tangent to a circle, then the two segments are congruent. So given this figure, we say if SR and TR are tangent to circle Q, then we can say that SR and TR are congruent with each other. Let's have this example. So given this figure, if SR is x minus 24 and TR is 50, if SR and TR are tangent to the circle Q, let us find the value of x. So using the theorem, knowing that SR is congruent with TR, we substitute the value of SR, which is x minus 24, and TR, which is 50. Solving for x, we transfer our negative 24 to the right side of the equation. That's why our equation will be x equals 50 plus 24. Adding 50 plus 24, so x has the value of 74. Let us identify tangent segments and rays. So in this figure, circle A, RM, line segment RM, and ray NT are said to be tangent to circle A. So RM here is called the tangent segment, while ray NT is called the tangent ray. Now let us deal with the theorems on angles formed by tangents and secants. Let's have theorem number 1. If two secants intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arc. So given this figure, circle Q, SR, line SR, and line TV are two secants intersecting outside the circle at point P. And arc RV and arc ST are two intercepted arcs of angle RPV. Our theorem states that for us to be able to get the measure of angle RPV, we will just get 1/2 of the positive difference of the measures of RV and ST. Let us have this example. So given our circle Q, the measure of RV is 140 and the measure of ST is 30. Okay, let us find the measure of RPV. So we will be using the formula measure of angle RPV equals 1/2 times the quantity measure of RV minus the measure of arc ST. So the measure of RPV equals 1/2, substituting the value of RV, which is 140, and ST, which is 30. Then we subtract 140 minus 30, we have 110, and getting 1/2, 1/2 of 110. So the measure of RPV is 55. Let us have theorem number 2. If a secant and a tangent intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intersected arc. So we have here our circle. So SR or RS is the secant line and RT is the tangent line that is intersecting outside the circle Q at point R. So SET here, the major arc here, and VT are two intercepted arcs of our angle SRT. The theorem states that for us to be able to get the angle, the measure of angle SRT, we just need to get 1/2 the positive difference of SET and VT. Let us have this example. So given that arc SET is 186 degrees and arc VT is 70 degrees, let us find the measure of angle SRT. So the measure of angle SRT can be solved using 1/2 the measure of arc SET minus the measure of arc VT. So the measure of angle SRT is 1/2. Substitute the value of arc SET, which is 186, minus the measure of VT or arc VT is 70. So 186 minus 70 is 116. And then we are going to multiply 116 by 1/2 or simply dividing 116 by 2. So the value of or the measure of angle SRT is 58. Let us move on with our theorem number 3. If two tangents intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arcs. So given this figure, so MR or line MR and MT are two tangents intersecting outside the circle O at point M. So RST here and arc RT are two intercepted arcs of our angle RMT. So line RM and line MT can form an angle which is angle RMT. And we can obtain this angle by getting 1/2 the positive difference of arc RST and arc RT. Let us have this example. Given that the measure of arc RST is 250 and the measure of arc RT is 110, let us find the measure of angle RMT. So we can obtain the measure of angle RMT equals 1/2 times the measure of arc RST minus the measure of RT. Substituting the values of arc RST, which is 250, and arc RT, which is 110. Subtract 250 minus 110, which is 140. And then, we divide it by 2, or multiply by 1/2. That's why the measure of angle RMT is equal to 70 degrees. Let us have theorem number 4. If two secants intersect in the interior of a circle, then the measure of the angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So, in this figure, line SM and line RT are two secants intersecting inside the circle. So, we have the point of intersection which is inside the circle. So, we say that arc SR and arc MT are two intercepted arcs of angle 1, while arc ST and arc RM are two intercepted arcs of angle 2. So applying this theorem, for us to be able to get the measure of this angle, which is angle 1, we just need to get the 1/2 the sum of the measure of arc SR and arc MT. Same is true in getting the measure of angle 2. We just need to add the, the measure of ST and the measure of RM times 1/2. Let us deal with this example. Let us find the measure of angle 1. Provided that the measure of arc SR is 120 and the measure of arc PM is 100, we will be using the formula measure of angle 1 equals 1/2 times the measure of SR, arc SR, plus the measure of arc PM. Substituting the value of arc SR, which is 120, and arc PM, which is 100, we add this, we have 220, and then we divide it by 2 or multiply by 1/2. That's why the measure of angle 1 is 110. Let us also find the measure of angle 2. Given that the measure of arc ST is 60 and arc RM is 80, we can obtain the measure of angle 2 equals 1/2 times the measure of arc ST plus the measure of arc RM. Substituting the value, so arc ST is 60 and arc RM is 80 degrees. So working on the parentheses first, we have 60 plus 80, which is 140, and then we divide it by 2. So the measure of angle 2 is 70. Let us have another example. Provided that the measure of arc CR is 6x plus 5 The measure of arc MD is 4x plus 15, and the measure of angle COM is 120. Let us find the following: the value of x, the measure of arc CR, and the measure of arc MD. So, to solve this problem, we first need to find the measure of angle COR. So, the measure of this angle, which is COR. So, how do we find the measure of COR? So, we will be applying the concept of linear pair are always supplementary. So, it means that for us to be able to get the measure of COR, we will be using the measure of COM plus the measure of COR equals 180 degrees. So, this pair of angles will always form a 180 degree angle. So, substituting the value of COM, angle COM is 120 plus the measure of COR, which is unknown, equals 180. So, the measure of COR, or this part, is 60 degrees. Now, we are ready to find our x. So let us find the value of x. So for the solution, we have the measure of COR equals 1/2 times the measure of arc CR plus the measure of arc MD. Okay? So since the value of angle COR is 60, we just substitute it equals 1/2. So the measure of arc CR is 6x plus 5 plus the measure of arc MD, which is 4x plus 15. So we simplify first by combining similar terms. We have 6x plus 4x, which is 10x, 5 plus 15, which is 20. And then we need to simplify it by multiplying both sides by the common denominator, which is 2. So the next line will be 120 equals 10x plus 20. So since we want to solve for x, we want our x to be alone on one side of the equation. So we transfer our 20 to the left side. We have 120 minus 20 equals 10x. Simplifying, we have 120 minus 20, which is 100, equals 10x. And then we divide both sides by 10. So the value of x is 10. Now let's move on in finding the measure of arc CR. So for the solution, in finding the measure of arc CR, so the measure of arc CR is 6x plus 5. Knowing that the value of x is equal to 10, so we need to substitute the value of x to 10. That's why we have 6 times 10, which is 60, bring down plus 5. So the measure of arc CR equals 60 plus 5 is 65. So it means that this one, the CR, is 65. And let us solve for the measure of arc MD. So for the solution, in finding the measure of arc MD, so the measure of arc MD is equal to this one, 4x plus 15. And knowing that the value of x is 10, we just substitute the value of x into 10. That's why we have 4 times 10 plus 15. So 4 times 10 is 40 plus 15. 40 plus 15 is, the measure of MD is 55. Now let's deal with theorem number 5. If a secant and a tangent intersect at a point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So we have here our secant line, which is SR. And we have here our tangent line, which is PM. They are intersecting at point R, or the point of tangency. Our theorem states that for us to be able to get the measure of this angle, SRP, we just need to get the 1/2 1/2 of the measure of this intercepted arc, which is SR. Same is true with getting the measure of this angle, which is angle SRM. We just need to get the 1/2 of the measure of STR, or arc STR. So let's try to illustrate this theorem. Okay, given this figure, let us find the measure of angle SRP. If the measure of arc SR is 170, what would be the measure of the angle SRP? So, simple as measure of SRP, angle SRP is equal to 1/2 the measure of our arc SR. So, we simply divide 170 by 2. So, 170 by 2 divided by 2 is 85. So, the measure of this angle is 85. Okay. What about the measure? Let us find the measure of angle SRM. If the value of our arc, this one, arc STR is 190 degrees. So same is true with the first one. The measure of angle SRM is 1/2 the measure of its intercepted arc, which is STR. So STR is 190, we substitute, and then we just divide it by 2. So the measure of this angle SRM is 95. Before moving on to our next theorems, let us illustrate first what is an external secant segment. So an external secant segment is the part of a secant segment that is outside a circle. Provided that we have this figure, RM and SM, line RM and line SM are secant lines. So we say that our PM and TM are external secant segments. So let us now have the theorems on secant segments, tangent segments, and external secant segments. So for the first theorem, it states that if two secant segments are drawn to a circle from an exterior point, then the product of the lengths of one secant segment and its external secant segment is equal to the product of the lengths of the other secant segment and its external secant segment. So provided that we have this figure, in this figure, line segment RT and line segment ST are secant segments drawn to the circle from an exterior point, which is point T. So from the theorem, it states that RT times AT is equal to ST times PT. Let's try working on with this example. If the measure of line segment RT is 16, the measure of line segment SP is 10, the measure of PT is 8, and we are asked to find the measure of line segment AT. So for the solution, applying the theorem, we can have line segment RT times the measure of line segment AT equals the measure of line segment ST times the measure of line segment PT. So substituting the measure of RT, so this whole one is 16, and the measure of AT, line segment AT is X, and line segment ST, so since this one is we just need to add the measure of line segment SP and line segment PT to obtain the measure of ST. And line segment PT is 8. So we work on the parenthesis first. 10 plus 8 is 18. So 18 times 8 is 144. 16 times x is 6x. To solve for x, we need to divide both sides by 16. So the value of x is 9. Now let us have our theorem number 2. If a tangent segment and a secant segment are drawn to a circle from an exterior point, then the square of the length of the tangent segment is equal to the product of the lengths of the secant segments and its external secant segment. So provided this figure, SA, line segment SA here, is a secant segment drawn to the circle from an exterior point, and our line segment RA is a tangent segment that is also drawn to the circle from the same exterior point, which is point A. So from the theorem, it says that the measure of this line segment RA, we just need to square it, and that would be equal to SA, or the measure of segment SA times the measure of PA. Let us have this example. So provided that the measure of RA, line segment RA is 10, and line segment SA is 25, let us find the measure of this line segment PA. So for the solution, from the theorem, we can obtain that by squaring our line segment RA equals the measure of line segment SA times the measure of line segment PA. So let us substitute. The measure of RA is 10 and SA is 25 times X, which is PA. So we have the square of 10 is 100. 25 times X is 25X. To solve for X, we divide both sides by 25. That's why the value of X is 4. So it means that the measure of this line segment PA is 4. Let us have another example. Given that PR is equal to 6, line segment PR is equal to 6, and line segment RA is equal to 4, let us find the measure of line segment MA. So for the solution, we can have the square of the measure of MA, line segment MA, is equal to the measure of line segment PA times line segment RA. So line segment MA is X equals PA, or the entire one, can be obtained by adding the measure of PR plus RA. So 6 plus 4. And then the measure of RA is 4. So simplifying, 6 plus 4 is 10. That's why the square of X is, the next line would be the square of X, which is X squared, equals 10 times 4. So we have X squared equals 10 times 4 is 40. So for us to be able to solve for the value of X, we need to get the square root of both sides. So the square root of 40 is 2 square root of 10. So the value of X is 2 square root of 10, or approximately 6.32 units. Let us try to define the theorem on two intersecting chords. So if two chords of a circle intersect, then the product of the measures of the segments of one chord is equal to the product of the measures of the segments of the other chord. So in this circle, so we have here SM, line segment SM, intersects PR at point O. So from the theorem, it states that the measure of SO times the measure of MO is equal to the measure of TO times the measure of RO. Let us have this example. Provided that SO is 12, MO is 7, TO is 8, let us find the measure of line segment RO. So for the solution, we will be applying the theorem on two intersecting chords. That's why we have the measure of SO times the measure of line segment MO equals the measure of line segment PO times the measure of line segment RO. Substituting, SO is 12, MO is 7 equals the measure of PO, which is 8, and of course, the missing one, the measure of line segment RO, which is X. So we simplify, we multiply 12 times 7, which is 84, equals 8 times X, which is 8X. And then we simplify, we solve for X by dividing both sides by 8. So the value of X is 10.5. Try doing this on your own. Until our next session, thank you and enjoy learning.